All right, what we're going to do is we're going to do some practice determining what happens when we shine colored light onto colored paper. And to begin with, let's just start with something simple. Let's start with a white piece of paper. White is so simple because white reflects everything. Okay, so if I have a white piece of paper, any light I send in gets reflected. Okay, so that makes it pretty easy. Now, but we're going to break down light into red, green, and blue. Okay, like we discussed earlier in the video. So let's say I imagine I've got yellow light coming in. Yellow light is made up of red and green. Okay, so if I send in red and green, well, what white paper does is it reflects back out anything that I put in. So the red's going to get transmitted, and the green's going to get transmitted. And what is my eyeball going to see? The eyeball is going to see exactly what came in. Yellow came in, yellow came out. It's the white piece of paper will look yellow under yellow light. Pretty self-explanatory. I think that's pretty simple, okay? But we're going to make it harder than that, of course. So let's look and see what happens when we take a colored piece of paper. And I'm going to start with a colored piece of paper that's a primary color. Let's start with blue. So I got a blue piece of paper. And again, this blue piece of paper is going to be blue because when you put white light on it, which is made up of red, green, and blue, only the blue comes out. So if you have a piece of paper that's a primary color, it absorbs two of the other colors and only transmits the color that it is. Okay, so here's my blue piece of paper. Now, let's send something in less boring than white light. Let's send in yellow light. Okay, if I send in yellow light is red and green. Now, what does blue paper do? It reflects blue and it absorbs the other two colors. Okay, well, I've only sent in red and green. That's what yellow light's made of. Okay, so if I send in yellow light and it absorbs both those colors, no light is going to escape. Okay, I have absorbed both of those colors. My eyeball over here sees nothing. And what do we call that when we see nothing? We call that black. Okay, so if I take a blue piece of paper, shine yellow light on it, I see black. Try another color. Let's send in magenta. Okay, magenta is made of red and blue. So here comes my red and blue. Okay, now again, what does a blue piece of paper do? It reflects blue, absorbs everything else. Okay, so the red's going to get absorbed. The blue is going to be reflected. And my eyeball sees blue. Okay, so magenta light, here it is, red and blue together, shining on blue paper appears blue. Okay, so for primary colors, it's pretty easy. You're only going to see either the color that it is, which is blue, or nothing. You're going to get blue or black because it cannot make combinations because it can only reflect one of the primary colors of light. Okay, let's do a piece of paper that is not a primary color. Okay, so I'm going to do yellow. So if I have a yellow piece of paper, I know that's a little harder to see, but I think we'll be okay. So here's my yellow piece of paper. The idea of yellow paper is that white light that shines on it will appear yellow. In other words, it will appear yellow because red and green are being mixed together to make that yellow light that we see. So that means yellow paper transmits or reflects red and green, but absorbs the leftover color, which is blue. You notice that's also its complementary color. Okay, so it absorbs its complement and reflects the rest. So let's say, for instance, I decide I want to shine in magenta light. So magenta will come in, being a combination of red and blue. Okay, yellow can absorb the blue and reflect the red. So what are you going to see over here? We are going to see red. I shine magenta light on yellow, I see red. Let's try cyan. I put in cyan. What's cyan? Cyan's a combination of green and blue. Okay, once again, yellow absorbs blue, transmits the others. So the green's going to come out. I shine cyan light on the yellow paper. It looks green. Let's keep going. Let's try a primary color. Okay, if I shine a primary color on there, say red, well, red's going to come right back out, and it's going to appear red. Okay, I think you can see that because it only absorbs one color, blue, any color that's shown on it that doesn't have blue in it, namely red, green, and yellow, which are the three colors that don't have any blue in them, you'll see exactly that color. Okay, any other color, cyan, magenta, or blue, the blue part of it will be absorbed and you'll see what's left over. In the case of cyan, because it's blue and green, the green's going to come back out and it'll look green. You send in magenta, which is red and blue, the blue is absorbed and the red comes back out. So on a yellow piece of paper, we can see quite a few colors. We can see red, we can see green, we could see yellow, which is the combination of those. Okay, and that's it. Okay, so we can see those three colors, and any other thing we shine in will appear to either be red or green. In the case of magenta, the blue gets absorbed and it still looks red. In the case of cyan, it'll still look green because the green gets absorbed. Now, if you shine blue in the complement, it actually appears black. That's the one other color we can get out of this, because blue light will get all absorbed and we'll get this variety. Okay, we are going to do some practice with this stuff. It will be on the quiz.